Welcome to the Connect studio. I'm Kelvin Ross, and today I'm joined by Terry Raddings from GE. Terry, do you want to come up?
Hi,
Hi,
Kelvin.
Terry. Nice to meet you. Thanks for joining today.
Pleasure.
We're going to talk gas turbines. So let's start off with what does the future look like for the gas turbine, or why is the gas turbine relevant today?
That's a great question, Kelvin. Well, the gas turbine is very relevant today. It's one of the, or if not the only way that you can get at-scale power onto the grid very quickly. It's very much so a supportive energy generation technique, which really does support wind and renewable energy. It kind of works hand in hand. So most people have a desire to build out wind or renewables, in just about any sector you can think of. The gas turbine is a very fast way of getting energy onto the grid to support that.
Mm-hmm.
So we see that as very much a sort of hand-in-hand technology.
Mm. Yeah, you said a supporting role there, and for quite a long time there was this view that gas and the gas turbine was a sort of bridging fuel to renewables, and then with the assumption that that bridge would perhaps one day go away and all things would be renewables. But do you think that's changed, and now gas and gas turbines are seen as the companion piece, if you like, to renewables? They're two bits of what is the near future's decarbonised picture.
Yeah, I think so. Very much so. Very much a sort of partnership. A collaboration. The wind and renewable is intermittent, as you know, and is not dispatchable, and so you need something there that supports that and also provides inertia to the grid, and this type of thing, and frequency response help, balancing the grid, which is very much so the need. And I think that as we grow out the renewables, as you know, GE is very much in renewables as well, not just gas turbines, for good reason. Then you can really sort of support that build out, and provide that fast energy and balance the grid, which is very much so the need. And I think that as we grow out the renewables, then the way that we balance the grid is going to be different. The way that gas turbines support the grid is going to be different. It's not just going to be about just providing megawatts. It's going to be about providing that reactive power, that grid frequency response, that balancing reserve, the stuff that you can't really predict very well. So if we're looking at what's the grid going to need at 9 o'clock next Tuesday morning, it's very hard to predict, but nevertheless, people need energy, and that energy needs to be supplied to the grid, and the grid needs to be balanced. And it's not just about gas turbines; it's about bringing all of the technologies together to provide that balanced network.
Mm. And do you think the grid is fit for purpose at the moment to balance that network?
I think there's weak points on the grid. I think there will be some investment required to support it, and that's happening. At least in the UK, the national grid is in the process of developing those services that are going to be out there, those ancillary services that are going to be providing some of that revenue stream. The operation is going to be different. Maybe I won't shut my gas turbine down at night time. Maybe I'll need to be there ready to roll in the morning. Maybe if I get connected to the grid, maybe I'll stay on the grid for longer. So there's all of those elements need to kind of work together and facilitate those types of changes and those types of things that are really developing and in the way that the energy grid is today and how that's supported. That it really you need that sort of support to provide that service.
Yeah, yeah. There's a lot of concern this year, for obvious reasons, about the availability of natural gas. How has that affected the gas turbine sector?
It's interesting. So I mean, as the technology itself, not really an awful lot, because the gas turbine is a tremendously flexible and versatile, energy production method or energy production technology. So from that point of view, not really an awful lot. I mean, the gas turbine. We developed this, what we call a wide wobby index, so that it can burn different types of fuel, and we kind of envisaged that LNG and that type of thing will be coming from different parts of the world, which it is, in with quite a lot more gusto than maybe before. We've been importing LNG into the UK from Australia and far flung places. So what happens when something becomes in demand, then the price goes up, which I think a lot of people are feeling in their pockets at the moment. So it's about having enough of it, and as we head into a kind of this end of the winter, and we're not quite sure of how that's going to shake out. Then there's been quite a lot of filling up of storage, and maybe even bringing out some coal fired power stations out of sort of retirement or mothballs, in order to be ready to to support that if we need it. I mean, even in the UK, coal import has gone up. When we only really have 3 coal-fired power stations left, and the intention is not really to use it, but it's just there in case we need it. And so there's the natural gas element of it, and people are worried about that. And as I guess it comes down to a lot of the infrastructure as well that you have to import the LNG. A lot of people see maybe Spain and the UK and those types of countries as a kind of a landing stage for for that onward transmission to the of that sort of gas supply to where it needs to be. But I would say as well that there's also a degree of looking at alternative fuels, backup fuels, which we didn't really envisage happening, but it's kind of the nature of the change. If we were talking about pre-February last year, if we were in a time machine and gone back to this time last year, then this wasn't envisaged. So how you roll with those changes and how you diversify quickly to cater for that. So the biggest impact is on the pocket. So efficiency is important. And so people look to well, do I need a backup fuel? Is energy security of supply is now is it really something I need to worry about? So we get a lot of questions from people asking, well, do I need a backup fuel? And if I do, then what does it look like? Is it climate friendly? Is it a bioethanol? Can I do that? Is it a synthetic natural gas or a renewables natural gas? So people are looking at those types of alternatives very much so, and there's quite a lot of production of those types of fuels around in our particular sector of Europe. So it's a question of like tapping into that, but the gas turbine is inherently a very fuel flexible machine.
Yeah, and so the notion of running a gas turbine on alternative fuels isn't new, and there's a lot of talk at the moment around hydrogen, but I'd imagine there was a time in your career when you were talking about running a gas turbine on hydrogen, maybe years ago. And
yes, very much so. Yeah,
right.
Yeah.
But you didn't because the infrastructure isn't there to get the hydrogen to the turbine.
Correct. Yeah. I mean, it's interesting because it's a bit like what I kind of think of it as Back to the Future. Because we've been burning these types of fuels, of high hydrogen fuels. And when I'm talking about high hydrogen fuels, I mean in excess of 40% by volume. We've been doing that for for decades. Mainly in refineries or in integrated gasification combined cycles where we were actually gasifying coal. The resultant of that is a high hydrogen fuel. So we've been utilizing those fuels for a while, for a long time, in fact. I guess what's different is that back then we were, really utilizing diffusion type combustion. So it's a bit akin to, your gas cooker. You want a little bit more heat, you turn the gas cooker up, but you still have to control the emissions.
Yeah.
And then along came the premix or the dry low NOx type of combustion systems. And so we utilize those. We wanted really a version of that burns high hydrogen, which is kind of the development. And we actually did that on our H-class machines. But that's pretty much what we have today. So micro mixer type technology. But its birth was actually in hydrogen. But the market never really, took off in the way that, that we're kind of rolling up to now.
Yeah.
And so we took that technology, we applied it to natural gas, and now it's like back to the future. Now we're really seriously talking about producing that, and we can do that right off the bat. With our H technology, we can go straight to 50%. We're trying to go to the next step will be 100%, but you need about 3 times more volume of the hydrogen versus natural gas.
So this is the thing, the burning hydrogen in the gas turbine. It's not a technology issue because you can do it. But the issue is still getting that supply chain, which at the moment doesn't really exist, to the turbine, to the gas plant. So, when do you think that will happen? What needs to happen to get that circle going?
Yeah, I think right now there's lots of competitions and this type of thing going on. It's certainly in the UK where, they're looking at incentives to get people to sort of start to build out the hydrogen infrastructure that's required. Sort of clusters and hubs where that hydrogen is produced, and maybe not just used in power generation, but used in transportation or in production of chemicals or this type of thing. So location is quite important. Refineries, that type of infrastructure is already kind of producing hydrogen to some degree. So maybe that's a good place to start.
Right.
Also then, either whether it's, all the colours of the rainbow of different types of hydrogen, whether it's blue, green or whatever, then there's also incentives to look at things like autothermal reformers and this type of thing, even electrolysis, but all of those elements, of producing hydrogen, it's not free, so the challenge is really in the production of that fuel that's required. Can we utilize it? Absolutely. In fact, it wasn't that long ago we were, with the Towns gas, which was a hydrogen-based gas. We were lighting buildings with it. In fact, up to about 1900, we were lighting the Houses of Parliament in London with Towns gas. So it's not something that's new to us. But the supply chain is, and when we talk to a lot of our customers, they're really interested in the capability of new product that needs to be built out, and also in terms of the existing fleet, how do we keep that relevant? So we're in the process of having a combustion system that as I described before, that does that and keeps those plants relevant. So again, the geography comes quite a lot into that. Where those plants are, where they're located next to. Is it close to a hub? Does the hydrogen need to be piped there or transported there, or is it right next door? It's those transportation and storage and shipping elements really need to be addressed. And we want to do that quite quickly. So it's the technology is there. We can do that now. So and we've been doing it for a long time, so that's not the hold-up. I think it's really the infrastructure. And so we talk to a lot of our customers. Is the gas going to come down the existing gas pipeline? Is the existing gas pipeline, can it facilitate that? Can it handle that amount of volume, or or just the hydrogen in itself? Because obviously hydrogen's a different element to, say, the natural gas. It doesn't like a lot of flange connections and things like that can permeate through. And you have to worry about the safety elements of it as well, and so it has to be handled in the right way. And which is all perfectly doable, but just needs to be thought about and kind of designed in, or even brought in, and so that plant can operate on those types of fuels. If it wasn't originally intended to do that, then I'm going to have to do that. The hydrogen flame is practically invisible, so I need special flame detectors. It behaves in a different way, so I need to be able to make sure that the plant's safe as well.
Yeah. I liked your Back to the Future thing. It'd be interesting if we're sitting here in a year's time, if we're still going back to the future to look to the future. Terry, it's been a pleasure. Thanks very much for joining me today. Don't forget you can catch this interview and all the other Connect interviews on enlit.world. But for the moment, thanks for watching.